Hello students, myself Meenakshi, Associate Professor Chemistry, SD Government College, Piyawar, Rajasthan. Today I want to discuss topic metal ligand equilibrium in solution, stepwise and overall formation constant. So just starting this topic, we have to discuss some introduction about stability constant. One of the interesting aspect of the coordination chemistry is the study of metal complex formation in solution. Stability constant of metal complex were first reported at the beginning of the present century. To understand the solution chemistry of metal, we must know the nature and stability of the complex that the metal ion can form complexes with the solvent and ligand in solution. Many important applications of this information are made. The term stability can be used in a number of different ways. The statement that a complex is stable rather loses since several interpretations can be placed upon it. When the term stability is used without qualification, it means that the complex exists and under suitable condition it may be stored in a long time. The term cannot be generalized for complexes since a complex may be quite stable to one reagent and may be decomposed readily in presence of another reagent. For example, when ammonia solution is added to a solution of hexa aqua copper 2 ion, four of the water molecules are eventually replaced by ammonia molecule to give CuNH4 H2O twice 2 positive ion. This can be written as an equilibrium reaction to show the overall effect. CuH2O whole 6 plus 4H3 will give CuNH3 4 H2O twice 2 plus ion 4H2. In fact, a variety of product result, the water molecule get replaced one at a time, and so this made up of a series of part reaction. The again water molecule CuH2O6 plus 4NH3 will give CuNH3 H2O5 plus 1H2 plus H2. Then this will give four of the water molecule are replaced by ammonia molecule. On a strictly statistical basis, one would expect that the relative number of H2O and ammonia molecules surrounding cupric ion would be the same as the relative number of ammonia and H2O molecule in solution. That is, if the solution contains equal number of ammonia and H2O molecule, the predominant cupric species should be CuNH3 thrice, CH2O thrice, 2 positive ion. Metal ion exhibit marked preference for certain ligand. For example, cupric ion coordinate ammonia in preference to H2O. In some cases, the preference of metal for certain ligand is readily understood. In general, however, the factors that determine which ligand will coordinate best with a given metal ion are numerous and complicated and are not completely understood. Consequently, many studies have been made to establish the composition of the coordination sphere of metal ion in solution in the presence of a variety of possible ligands. The information collected in this study is conveniently expressed by stability constant. In studying the formation of constant in solution, two kinds of stability came in question. First is thermodynamic stability and second is kinetic stability. What is thermodynamic stability? This is a measure of the extent to which the complex will form or will be transferred into another species under certain condition. Which the system has reached equilibrium. When we are concerned with this type of stability, we deal with the metal ligand bond energy, stability constant and several thermodynamic variables which are derived from them, or with the redox potential which measure stabilization of valence states. According to thermodynamic stability, the reaction between metal ion and ligand may be considered as a Lewis acid and Lewis base reaction in solution. If this reaction is strong, the complex obtained is thermodynamic stable. The next is kinetic stability. Kinetic stability is mainly for complex in solution. It deals with the rate and mechanism of chemical reaction. For example, substitution, isomerization, racemization, electron transfer reaction, as well as with the thermodynamic variable involved in the formation of activated complex or intermediate species. In the kinetic sense, it is more proper to call the complex inert or labile complex rather than stable or unstable complex. The complex in which the ligands are rapidly replaced by other ligands are called labile or non-inert complexes, while those in which the ligands are slow, in which substitution occurs slowly, are called inert complexes. According to Handy and Taub, those complexes at 25 degrees centigrade occur reaction. These are called complex reaction complete. They are called labile complex. And those which not complete reaction at 25 degrees centigrade at 1 minute are called inert complex. Up next, we have to discuss stepwise and overall formation constant and the interaction. According to J. Barham, in 1941, the formation of complex ion solution proceed by the stepwise addition of the ligand to the metal ion. Thus, the formation of the complex MLN, where M is central metal ion, L is ligand, and N is the maximum coordination number of the metal ion. For each of the equilibrium, we can write an equilibrium constant expressing using the law of mass action. Omitting the solvent molecule whose activity remained constant if low concentration are assumed, we obtain the following expression. M plus L will give ml. K1 is stepwise stability constant. According to law of mass action, it will be ml upon concentration of M into concentration of L. Such type, this is according to mln minus 1 plus L will give mln, and kn mln mln minus 1 L, where the equilibrium constant K1, K2, Kn are known as stepwise formation constant or a stepwise stability constant. The formation of the complex mln, it can also be expressed by the following step and equilibrium constant. For example,